Let's come to the final presentation. We're unfortunately a little bit delayed, but I think we have still some very exciting news to hear. Next speaker is Tomaso Charlemont. For a long time in solar, since recently the product lead revamping and repowering of solar power plants. I think an interesting topic that will we will have to deal much more with. Tomaso, the floor is yours.
Yes, thank you very much, Michael. Can you hear me? Can you see me good?
Yeah.
All right. So yeah, thanks for the introduction, and thanks for giving me an opportunity to present here, because this is going to be a subject which is quite different from what we have seen so far. We've been hearing from equipment manufacturers, module manufacturers. We've been hearing from Jan about recycling technologies. We've been hearing about backsheet manufacturers. So very interesting. I would like to give you a little bit a perspective on what happens in the real world on projects which have been built a time ago, and how today we think and we believe that we can improve sustainability of solar projects. So let me share. Are we good to go? I'm gonna speed up maybe a little bit on some non-essential points, because I understand that we got some delay. So just a brief introduction about BayWa, and I will talk about why modernize and retrofit PV assets as part of improved sustainability. How does new equipment impact existing assets? We're going to talk about revamping and repowering, just to make sure everybody understands what these two disciplines are. And then we'll talk about the value of decommissioned components, and then jump to some conclusions. Just a brief about BayWa, for those who do not know us. BayWa r.e, we got founded in 2009. By end of last year, we were roughly 4,000 people in 30 countries. Numbers, I can only share 21 numbers, because 22 results are going to be published today. And since we are a publicly traded company, I cannot share this ahead of time. So, but just to give you an understanding of the size of the company, 3.6 billion euro turnover, with an EBIT exceeding 160 million. And I can already anticipate that the 2022 results were much better. So we are a German origin company, headquartered based in Munich, Germany. And we do a number of things. And I have here a little plot on the right. We provide complete energy solutions to final users. We are involved with wind projects, solar projects, hybrid projects, which today hybrid projects is a mix of wind and solar and hydrogen and biomass and chemical energy storage as well. We have a business which is solar distribution. That is what we call solar trade. We distribute components for solar. We have a proper bioenergy business, and of course we do services and then energy trading. Now within services, that is where I am active. What we do basically, we offer a whole breadth of services to our clients, all aimed to ensure that the investment that owners have done in whatever wind or solar plant provides sustainable and reliable returns, because this is what we are all aiming for. So we do provide planning and technical consultation, operation maintenance, commercial management, so asset management as we call it. We do all the compliance with quality and standards, rotor service for wind as well. And we have something which is quite special, which is developing over the past years, which is the repowering and revamping of PV assets. And that's what we'll be having a closer look at and understand how that relates to sustainability. So one basic question that typically get asked is why would you want to modernize or retrofit PV assets? And here, some of my previous speakers will recognize it themselves because there are some very well-known phenomena that happen on early generation technologies. So we have this so-called chalking of backsheet, and then more frequently even have the complete degradation of backsheets. This is where we were just lacking the right experience in the solar industry, or maybe a little bit less professional manufacturers were not giving the right attention to quality as they should. But we have these modules which now, a number of years after having been in service, degrade very severely, and you end up having basically situations like this with backsheet almost completely disappearing, falling apart, exposing contacts, and then you even have this classical phenomena of module which is collapsing, and we see more and more of these. So all these, of course, are good reasons for replacing these components, because this is not happening 20 years after they have been installed. This is happening in some cases even less than 10 years since they have been installed. So there's definitely serious module manufacturers take the responsibility, replace modules under warranty. In other cases, modules come from manufacturers which no longer exist. So then it gets a little bit more complicated. And of course, we need to find solution for the asset owners. You also have, at some extent, phenomena which are much more recent in time, which can happen eventually any time after installation, and that is typically hail damage. We have modules which get slashed by hailstorms. So this is a picture of an asset that we maintain in the western coast of France. Large plant, 30 megawatt. Majority of the plant got hit by heavy hailstone storm. Hailstones as big as apples falling down that one day, where there's the consequent damages. And then on the opposite of the temperature scale, we also have cases of wildfires where it happens from time to time that the solar plants get caught by wildfires, and then you have definitely damages. Charcoal cable, and then end inverters, and then of course damaged backsheet on the module. So there are a number of good reasons for needing to modernize retrofit assets, and especially on the more technical side, when you see this backsheet degradation, this is where we started getting involved already a few years ago, when these phenomena started appearing, and customers and clients came to us and said, well, can you help us? And then it was clearly that it was no longer operation maintenance that was needed to be done there. It was a proper revamping of the solar plant. So we started doing this, and then we started understanding, what is the impact of replacing modules but also inverters that have been in the field for a few years already, in some cases, let's say 10 plus years. What happens? And here I would like to call you back to a slide which probably most of you have seen. This is this famous table which is published by NREL, which shows the big wealth of solar technologies and how the efficiency develops over time. And then typically what we realize today is that when we replace modules today with modules that have been installed, say roughly 10 years ago, well, the efficiency of the modules goes from an average of 14 and now to 24%. Very interesting. It was in the press this morning. There is one of the module companies which was presenting this morning who already have announced efficiencies reaching 26%. So this does not mean necessarily that it is the same technology which is improving in efficiency, it is in evolution of efficiency. So a few years ago, the most popularly installed modules were, as you remember, there were polysilicon, there were amorphous silicon, CIGS, cadmium telluride, and now everybody's installing a PERC technology and moving into TOPCon, etc. So when we replace those technologies with what is mainstream today, we have a dramatic increase in efficiency. And looking forward, well, this will keep increasing. We already have seen announcements made a few months ago of newer technologies like perovskite tandem cells exceeding 30% efficiency. So we already know that this trend of increasing efficiency of solar cells and then of solar modules will keep growing. On the other side, if you take, for example, inverter technology, 10 years ago, when we were installing inverters, a typical 250 kilowatt inverter would be a cabinet that size taller than a man, weighing maybe a couple of tons, a huge piece of equipment. I sold many of those at that time. Well, today, the same kind of inverter you hang basically on a rack on the structure beneath the modules. So there's a huge difference and definitely in size and weight. But what really is interesting is that we have a huge difference also in efficiency. So inverters have become more efficient. So we go from a 96 to a 99% efficiency today. So this is what actually is now generating this impact on when we start changing equipment to a solar asset. So I'm going to show you a couple of examples, and these are real life examples, which will give you a better understanding of what is happening today. These are the numbers of a plant that we have revamped in the UK a couple of years ago. And then again, I'm pointing out here what we have done, what was the scope there. We have replaced the central to string inverters. We have replaced the cast resin to oil step-up transformers. We have completely redone the AC cabling and the switchgear. As a result of that, the performance ratio went up by almost 39%. And the numbers are plotted here. And we have not changed the modules there because in the UK, it is not that easy to get approval for replacement of modules. The law is quite restrictive. Nevertheless, the increase in performance was dramatic for just that one single operation. Going further south, a very interesting example in Italy. In Italy, the law authorizes asset owners to do revamping, but because the law does not forbid to replace the underlying structure and does not forbid to change the layout, what happens here is that very often we can go from a fixed tilt installation like we see here to tracker. So on this very project here, which was called Manduria, we have replaced a cadmium telluride thin film modules with mono PERC. We have replaced the fixed tilt with a single axis tracker. We have kept the original total installed capacity of 7.5 megawatt because this is what was required by the feed-in tariff contract. And by doing this operation, the performance went up, the PR ratio went up almost 23%, and the yield went up almost 40% by having done this operation. Now you can imagine you do this work on a project which has a feed-in tariff contract which was signed 10 years ago, and there's 10 years to go with a yield increase of 40%. This is what definitely makes the asset owner very happy. There's another project that I would like to showcase. That's the one that we did in France. Here we have done something a little bit more complex, and I say there is a work in progress, and you will see. The original site was equipped with amorphous silicon thin film modules, and we have replaced them with mono PERC. We have been able to increase the total installed capacity by 10%. So from 5.4 megawatt, we went to 5.9 megawatt. And this 10% is a tolerance which is given in France by the local authorities. So you see that the markets are also different from one to the other. But just doing that, keeping the fixed tilt installation, just replacing the modules, we have not replaced inverters, PR went up 37% and yield went up over 38%, just replacing the modules. Now, interesting enough, because of the higher efficiency of the modules, land occupancy has been reduced by 43%. So that's another way of approaching this. And here it gets really interesting, because now we have land that have become free, and the asset owner now can add another 4.1 megawatt on the land that became free following to the revamping. There's no permits required, because there already are the permits for installing a PV plant on that land. There's just a need for a new grid connection for the additional capacity. As a result, the same land is now going to host 85, almost double the total installed capacity it had before, and going to generate cumulated between the two, let's say, parts of the plant, basically more than double, almost 2.5 times the energy that was being produced before. And here it's where it gets really interesting, that out of a necessity coming from a technical distress that asset owners were experiencing, we have discovered something extremely virtuous. And that is what is now called revamping and repowering of solar assets. There's two very clear definitions. Revamping is the replacement of defective or underperforming PV components whose performance no longer meets original specifications or expectations. So this applies to plants where we just restored the original installed capacity in megawatt peak, because there is a contract existing for the export of the energy. The contract says that the plant has a total capacity of so many megawatts, and that needs to be respected. Nevertheless, new components, because they're more efficient today, will improve energy production, increasing yield by up to 40%, allowing more efficient use of land by 30 up to 50% in certain cases. Now, of course, that depends, is from what technology to what technology are you going. So if we take very low performance amorphous silicon or cadmium telluride modules of 10 years ago, etc., and replace it with mono-PERC, the progress definitely is much bigger. If you take maybe, I don't know, call it some power modules that were installed 10 years ago, they already were mono technology, and so the gain may be a little bit less. But then again, those modules, they may not be facing this kind of technical distress that other technologies are facing. But nevertheless, the revamping is when we take an existing plant and basically restore the original capacity. Now, because of land becoming free, then there is a concept of repowering, where repowering is a plant redesign that aims to maximize total system capacity within the limits of the land area of the original plant. So you have a certain number of hectares or acres, as you want to call them, you have a permit to build a solar plant on that, and you want to stay within that land. The fact that land has become free through the revamping typically motivates asset owners to repower or put new capacity on the piece of land that became free. So repowering can refer to additional power that can be added following to a revamping on the freed up land. But repowering can also regard the addition of new technologies. So in some cases, that would be very interesting to explore as to the installation of energy storage infrastructure, because now there is room for putting that into place. And that is something which can be very interesting. In any case, you have an extension of the lifespan of the plant, because you're basically building a brand new plant, or in both cases, you're putting in new equipment. So these are the two concepts that have been developing out of this necessity that we're giving. So one question which often gets asked is, so how big can that market be? And how much can you estimate the potential for distressed assets going to be? Because not all assets are indeed going to require revamping or repowering. So because there are no specific market studies or market research to identify assets which are in distress, we have taken Wood Mackenzie's analysis of what we call the forecast of solar systems operating beyond 10 years inverter lifespan. And why is that important? Because this chart here gives us the indication which is the percentage of operating inverters reaching end of life. And inverters typically reach end of life halfway of the life of a solar plant, which is typically anyway between 10 and 15 years, depending on the technology. And this gives us an indication where we say, well, if there's a need to replace the inverters, that may be an opportunity to also have a look at what is the status of solar modules. And so we have taken that as an indicator, saying, well, if we replace inverters, then we may replace modules as well. But so that is just one indicator. One definite indicator is what we understand is the volume of solar assets reaching end of life, and that is typically 20-year-old systems, because then you have lease contracts, so you have energy or feed-in tariff contracts arriving at an end, and then that is the moment where projects typically represent the opportunity for a total refurbishment or repowering. And here we start having some trends and give us indication about how many gigawatts of modules actually are out there, or plants are out there that could be become interesting for revamping and repowering. So I have made a little extraction, and apologies for the audience which is outside of the EMEA region, but you will also understand, and you see here from the graph, that definitely EMEA is representing the largest chunk of this I would say market, with then America and APAC following. But for EMEA alone, just the revamping at end of inverter lifetime, and then adding repowering of end of life systems. So you're really talking about, in the excess of 4 gigawatt moving into the 6 gigawatt region by end of in a couple of years. So what we have done, we said is, so how do we measure then this in terms of number of modules, how much modules we will need to to handle in terms of dismantled equipment. And here we started plotting here some numbers and making some projections for up to the end of the decade. And if you take as just a ratio of the power installed, so what would be undergoing refurbishment, and then taking average weight of the installed modules and converting this into number of modules in tons, you see that within a couple of years we already have 500,000 tons of modules just in Europe, million, and that will basically double 2 years later, and then double again 2 years later. So probably we're exceeding 2 million tons by end of the decade. So this is interesting to have as an how can I say projection of just what will be coming. So for those who will say, well, the recycling industry needs volume, well, the volume will come, and again, this is just an indication of what we see coming and what will be let's say require assets which will require retrofit anyway. So one question then pertinent to sustainability, and here maybe I will be accelerating a bit, can be yes. Sorry?
You have to come to an end here.
Yes. So recycling, we have been talking about this. We have seen that more efficient solutions are coming. that eco-design is going to play a role. So definitely recycling will develop. We already have seen considerations about the fact that recycling may not be the only way out. So we talk about the reuse of solar modules, and also we have already heard from Jan that there is a work in progress, that there is a EU directive which will be released. So definitely the objective is to extend as much as possible the life of a module or all components and limit the waste to the very end. So as a conclusion, in terms of improving sustainable value, we consider and we see this trend developing, that it really is about maximizing the amount of energy produced per land surface. So I call it the kilowatt hours per square meter. And that is the more energy we will be able to produce, and that includes improving or doubling the energy production per surface, will definitely be the very first step towards improved sustainability, because in the end, the more carbon-free energy produced, the more sustainable solar will become. And at the same time, it will be paramount that we really recognize the residual value of decommissioned components, because there is a lot there. And it's not because we are dismantling modules that they need to be considered, trash. There is a lot to be recovered, whether it is materials or reuse of components. And then at the third point, of course, that is fostering circular economy, which is definitely going to be further improving sustainability of solar. Thank you for your attention.